In this video, we're going to look at all parts of question 1 in the voltage divider circuits exercises from page 59 of the Analogue Electronics course notes. So let's take each question in turn to look at what we're being asked. So we can start off with part A. In part A, we're told the resistance across both resistors and we're told the supply voltage. And this gives us all the information we need to use our formula for the output voltage from resistor 2. So using the formula we're given, I think on page 47 of the course notes, we can say the voltage across resistor 2, which is what our X value is here, is equal to the resistance of resistor 2. And just to be clear, when we say resistors 1 and 2, what we mean is resistor 1 is the top and resistor 2 is the bottom in the diagram, and that will be the same in all questions. The value of resistor 2 divided by the sum of the resistances of the two resistors multiplied by the supply voltage. So using the values in the question, we're going to have, well, interesting thing here is when we're doing these, because it's a ratio of resistance, we don't have to convert this to ohms. We can keep it as 22 and 18 rather than changing it to 22,000 and 18,000. It's one of those rare times we get away with not doing unit conversion. However, should you convert from kilo ohms to ohms, it will also still work. And you'll see why if you work it out. So we'll have 22 over 22 plus 18 multiplied by 9. So that leaves us with 22 over 40. And hopefully you can see 22 over 40 is going to be equal to 22,000 over 40,000, which is why our unit conversion is not particularly important here. So working this out here, we've got 22 divided by 40 times 9, which gives us 4.95 volts, which is of course the answer indicated as correct in the question. And since we've been asked to find X, we could take a further step and just say X is equal to 4.95 volts. And the reason for doing this perhaps will become more clear when we do part C. In part B of the question, it's a very similar setup, so I won't waste too much time in restating everything I said about part A. We're using the same formula, V2 is equal to R2 over R1 plus R2 times the supply voltage, and all of these values we need are given in the question. R2 is 15, R1 is 10, R2, we said, is 15, and the supply voltage is 5. So what we're going to be left with here is 15 over 25 times 5, and 15 over 25 is the same as 0.6, so 0.6 times 5 is 3, or you could just stick it all in the calculator, there's really no problem doing that. And of course we were asked to find V2, our X value, so we can say here that X is equal to 3 volts. Part C, a very similar type problem, except this time we're being asked to find the voltage of the top resistor. Now there's two different approaches we can take here. If you don't feel confident changing your formula about, then we could work out the resistance across resistor 2, the bottom resistor, and then subtract this value from 9 volts. We'll take in that approach in a second. Or if you felt a bit more confident, you could think, well, I know a formula for V2. Could I think of a similar formula for V1? And the answer is yes. We could come up with this formula here. V1 is equal to R1 over R1 plus R2 times Vs. All we've done here is take the R1 on the top in place of R2 on the top, and it's the same formula, except now it's going to give us a voltage across the top resistor. So if you feel confident, and usually we're interested in resistance across the bottom resistor, which is why we don't even bother giving you this formula in the course notes. But if you feel confident, there's nothing to stop you using that formula that I've listed in green at the top there, and it will work out the same answer. If, however, you decided to play it safe and think, no, I'll stick with the formula that I know already, and we'll solve the problem and then work out X afterwards, then we can go down this route here. So let's work out first of all the voltage across resistor 2. So here we have V2 equal to R2 over R1 plus R2 times the supply voltage, and that's going to be equal to, well, let's see what these things mean. 3K3 means 3,300, or you could write 3.3 kilo, 3.3 kilo ohms. They both give the same fraction here, and that means that 4K7 means 4,700, and of course we know that R2 3,300 multiplied by the supply voltage here, which is 9 volts. So we have 3,300 divided by 8,000 times 9. So putting all of this into our calculator, we get an answer of 3.71 volts for V2. But that's not what we've been asked to find in the question. We've been asked to find X, and X is the voltage across V1. So what we could say is that X is going to be equal to our total supply voltage of 9 minus the voltage across the second resistor, 3.71. Or maybe I should write first of all, X will be the supply voltage minus voltage 2. And that's going to be equal to 5.29 volts. And that's the answer indicated in the question. And so maybe as a wee challenge, you can convince yourself that the formula in green with our different values in there, putting them in will give us the same answer and show that that's an acceptable alternative way of finding the solution to part C. And that concludes problem 1 from that tutorial sheet.